just a little long rail. I know right now you can't tell. Oh, hello everybody. Let's go ahead and get to it, guys. Use the what we learned yesterday to find the side length of the square, and the edge length of this cube. See what you guys can do, and here we go. Alrighty, everybody. Can I get you back up here in 5, 4, 3, 2, 1. Okay, let's see here. Can I get a little bit of help out there? Let's go for voices off, please. Aria, what did you get as the side length of this square here? 4.6. Do you know the shortcut, or did you just do like guess and check? Yeah. Then the side length is 4.6, because if the side length squared is equal to 21.16, we know that's between 4 and 5, and if you do 4.5 squared, that's too low, so maybe you try 4.6 squared, and then you get it, 21.16. How many of us got that S is equal, or the side length is equal to 4.6 for that? Beautiful. Now, I want to point out, guys, this doesn't have a plus or minus this time. And the reason it doesn't have a plus or minus is because this can't have a negative side length of 4.6. Like, that's not a thing, is a negative distance. So since it was actually about a square, it's only the positive one. But if I just said S squared equals 21.16, I would expect to see that plus or minus 4.6. Camilla, could you find the edge length of that cube right there? 6. That sounds right. Because d to the third power is 216. Do you know the shortcut, or did you just guess and check? What was your first guess? Was it 6? Yeah, because a lot of people would try something like, I don't know, 11, and then you do like 11 to the third power, and it's like, oh, that's 20. Oh, that's a little high. And so you have to go way lower than 11, so like maybe 5, much better, and then we'll try 6, and you get there. Now, that absolutely will work, but guys, there's got to be a better way, and in fact, there is. Let's get to it, everybody. It is the 45th day of school. You know, 45 is the smallest odd number that has more factors than one more than itself. Okay, that is, here's 45. Name all the numbers that go into 45 evenly. Go. 5, 9, 45, 15, 3, 1. I think that's it. 1, 2, 3, 4, 5, 6. It's got 6 factors. Now, one more than 45 is 46. What numbers go evenly into 46? 46. 1, 2, and 23. So 45 is the smallest odd number that has more factors than one more than itself. And in fact, it's also the smallest odd number that has a greater sum of factors than one more than itself. Yeah, Rex. Oh, sure. Sure. That's true. I like that. I like that a lot. And if it was odd, you know it'd have to be odd as well. I like that a lot. It's Eat a Pretzel Day. Yay. I don't know if you guys feel the way I do. Sometimes I really, really, really do want one of those crunchy pretzels out of a bag. But generally speaking, the pretzels out of a bag are kind of mid. Yeah. But nothing hits quite like a big soft pretzel when they like butter it and put lots of salt on it, or like pretzel bites. Guys, who has better pretzel bites, Thirst or Swig? See, I completely agree. Who's got better drinks, Thirst or Swig? See, like so when you ask your mom, Mom, can we please get pretzel bites from Thirst and then get drinks at Swig? And she's like, no, because I'm the one driving. But yeah, how many of you when you're the one driving, you're totally gonna pick up your pretzel bites at Thirst on your way to Swig to get the drinks? Absolutely, absolutely. Alrighty, let's go, guys. What is our first essential question? And I would love to get that from Alex. What's our first essential question, sir? What is a root and how does it work? You're like, well, it's a part of a plant and it's the stem. No. What is a root and how does it work? That's okay, because that has nothing to do with what we're up to right now. What is our second essential question? I'd love to get that from Truman. Good. How can I write a root? Oh, you know, I really missed an opportunity to make that way more fun to say. How can I write a root reduced? That's way more fun to say. How can I write a root reduced? Famous Ben's Jeopardy! It's not the clock in Elizabeth Tower, but this Ben is rather the giant bell the clock uses. That is indeed Big Ben. Big Ben is not the name of the tower. It's not the name of the clock. It's the name of the bell in the clock. And then things that rhyme with hark, dark is what we're looking for, dark. Okay, let's get to it, guys. Underneath all this, got a pencil? Today, guys, it's time to get to the root of the matter. The root of the matter. Okay. What if I told you that g to the fifth was equal to 97.65625? Hey, whoa. Before you grab your calculator and do the shortcut, or if you're like, okay, here we go, time to guess and check. Like I said, your calculator is really, really good at coming up with, at guessing something. If it's too high, guess lower. If it's too low, guess higher. And the truth is, we just need to know how to ask it. Got a pencil? The anatomy of a root. You're like, oh no, phylum, not that kind. The anatomy of a root. A root looks like this. A check mark like this, kind of like you're doing the Van symbol. And it's kind of a European style. Like in America, they don't use it as often. But I personally like to put that little crook on there, because when you don't have the crook, sometimes it's a little confusing about when a root ends. And so I like to have that little crook on there to remind myself that's where my root ends. There's also a little number that lives inside the check mark like that. And there's a big number that lives under the check mark like that. That's what a root looks like. Every root looks like that. Now, sometimes they do something funny with it, but in the end of the day, every root's got two pieces of information it's trying to tell you, and the symbol tells you what's going on. Let's make sure we can talk about these things with in like grown-up language. The n, this number here, is called the index. So if I talk about the index of a root, I'm talking about the little number that goes inside the check mark on the top. The big number inside and under the check mark is called the radicand, which sounds like something that a Ninja Turtle would yell while kicking a foot soldier in the face. Radicand! Go ahead and write this down for me, Ira. Make sure we're meeting my expectations. Okay? That's okay. Hey, I'm taking care of it. And even though you don't need to know what this thing is called, I'm still going to tell you what it's called so you can get 1,000,000 points on Scrabble and have someone challenge it, because it's totally a word. That thing's called a radix. And that really sounds like something that Michelangelo would yell while kicking a foot soldier in the face. So, the index, the n, let's see here. You know what? I think that, honestly, the best way to do this, let me grab my notes. I want to grab my notes from a different class, because I did this in a slightly different order than I'm used to. So I think, there we go. That's the one. So you would pronounce this the nth root of a. That's how you'd say it out loud. The nth root of a. And it asks, what number, if I multiply n of them gives me a. I had a student one year who was like, gives me a what? I was like, it gives me a. And she goes, gives me a what? It gives me an A. And she's like, oh, it gives me an A. Wonderful. Then I love these. All right. Okay. Let me show you what that means. Like, I can ask this question. What is that saying out loud? If you read that out loud, Jack, if this says the nth root of a, what does this say?
That says the 8th root of 256.
Yes, the 8th root of 256. And it's asking, what number, if I multiply 8 of them together, is going to give me 256? Got a calculator? Here's how we type that into our calculator, okay? Let me zoom in on this a little bit so that we can actually do this so we can see it. There we go. So to type the 8th root of 256, first you have to type the index. The index is 8. Then you push the second key, and you see this right over here, the x root? That puts the 8 inside of the index. And now I can type 256 as my radicand, and it says, what number if I multiply 8 of them is 256? Why, it's 2.
Do we have to unclick the second?
It's 2. Nope, it's automatic. Perfect. How did I, let's show you again. Watch carefully. First, you type the index. The index was 8. Then you type the green second key. I think it's green for you as well. And then you have to hit the caret key because that's got the green x root hovering above it. That puts the 8 inside of the index. 2, 5, 6, enter. You have to be careful because there's another button over here, guys, that looks really similar that will give you a completely different answer. That I will tell you why in a little while. It's because the 8's not in the index. That's the short answer. The long answer is, what the heck's in that index? Let's talk about it. Okay, how does this help us? Well, guys, I don't know what number multiplied 5 times is 97.65625, but you know what? Who will? My calculator, if I take the 5th root of both sides, because what number multiplied 5 times is g multiplied 5 times? A g. And now I'm going to take the 5th root. Let's scooch this guy over here. The 5th root of 97.65625 is, it's 2.5. Should that be plus or minus or just the positive one? It should be whatever, it should be just the positive because it was an odd exponent. After seeing that once, how many of you are like, that makes sense, I'm ready to do that? After seeing that once, how many of you are like, I hate you for not showing me that yesterday? Totally. Most of you guys have a smile on your face while you're doing that. You guys, I don't know if you saw Juliet, but like, that was just like, the hand went up, and there was like no happiness or mirth in her eyes or mouth, and she was just looking at me like, if looks could kill, I would have just dropped dead like right there. She's like, how dare you make me guess and check that yesterday. I'm sorry, it's good for you. Because now you know what your calculator does. So hey, remember yesterday? Remember yesterday when I was like, x to the 3rd equals 15? Let's use a root to do that work for us. Teach! Yes. Maybe. Ah. When he just figured something out. Yeah. Oh, so that would have been from how many solutions? That's also full points for what it's worth. So you're good.
Okay, Mr. Peterson.
Yeah.
So Dean showed you the
Uh-huh. Yes.
how when you cube it, it doesn't
You're
work.
absolutely right.
But when I don't actually type it in, it just
Yeah. Okay. Uh-huh. 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 Yep, your calculator's not is kind of acting funny. I agree. That's part of today's lesson.
I think I got it right.
Oh, Edo.
2.466212074.
Let's see. What's that? Squeeze by you guys. Pardon, pardon. Ah. Oh, sorry, I knocked over your bag. Okay. Can I get you guys back up here in 5, 4, 3, 2, 1? Guys, I want to take you on a journey. So, well, before that, let's see here. What kind of root do we need to use to solve this, Dean? Well, sure, but what needs to go in the index? That's right. It's the third root or the cube root. It's a special root called a cube root. The third root of x or the cube root of x, either way is totally acceptable to say. And you get, let's see here, the third root of 15, third root of 15, and we're like, oh, nope, I'm hitting the wrong buttons, aren't I? Third root, don't take a logarithm, Mr. Petersen, of 15. Hooray, 2.466212074. We're going to round that to about 2.47. So x is about 2.47 because 2.47 to the third power is about 15. However, Lamhe actually figured something out here that deeply alarmed him. He was just being thorough. He said, well, let's do 2.466212074, and let's raise that to the third power to make sure it's 15. Too low, guess higher. Too low, guess higher. Now, here's the thing. Your calculator is having to round this answer. And Lamhe actually found out that when you take the third root of 15 and then just say, what's that to the third power? It'll actually give you 15 because it rounds to much more digits than you can see, like for itself. But the point that I'm trying to make, guys, is that this answer is not exact. This 2.466212074 is an approximation. I see a lot of hands. Let's go to Wenny.
So if you just add a 1 to the end of that number, it makes 15.
Sure, but
2.46621207441.
that could be, but allow me, if I may, to take us on a journey here, guys, to Wolfram Alpha. Wolfram Alpha is a website that connects you with the math supercomputers of like a bunch of different universities that have put them together. And so, Dwayne, you said that if I add a 1 to the end of that, then I will get 15. So, read that number with a 1, please.
2.46621207441.
To the third power. Too low, guess higher. So, maybe you do it too, right? Too low, guess higher. Now, here's the other thing. Now, actually, I'm gonna ask it right here. Cube root of 15. And I want to show you something. Look, there's your decimal approximation right there. 2.4662120743304. Oh, more digits? Certainly. Would you like more digits?
Yes.
Would you like more digits?
Yes.
Would you like more digits?
Yes.
Surely that must be the end. Oh no, more digits. So this is, there we go, really? Oh, well, I think you have to do the paid version if I want more digits. But guys, here's the thing. This number here, guys, yeah, if you take this number and raise it to the third power, it will not be 15. It'll be pretty close, but it'll be too high, I guess lower, right? So here's the thing. Remember like yesterday when we were doing this, I kept hearing people say, oh, it's a repeating decimal. And I kept saying, if only. Credence, do you have something you want to say about this?
I knew it was a repeating decimal because it went 7 and then 4. So if it had been 3, 3, 3, and then 4, then
Mm-hmm.
repeating decimal because they round up.
Then it could have
But
been,
they
yeah.
just round up before.
No.
So it keeps going.
So tomorrow we're going to talk a little bit more about this specifically and about what on earth we're looking at here. But for now, I want to take a step back because I want you guys to know that when you put in the root in your calculator, it's not giving you an exact. It's giving you an approximation, okay? When you get that big, weird decimal. So let's see here. Got a pencil? Let's do this. What is, if I told you that, let's see here. I want to do, what if I told you that y squared is equal to 675? Can you get me an approximation for what y is? Give it a try and teach. Shortcut people might get an interesting answer. The people who knew the shortcut beforehand, I mean. Those of you who didn't know the shortcut beforehand, you're probably going to get a nice, nasty decimal to round. Those of you who have been using the shortcut this whole time might get something else that makes you wonder. Aha, yep, indeed. Indeed. Yeah, right? Yeah, no, I think that's a beautiful answer. That's a beautiful answer. Yeah? So if, I would like to see opposites and balance, but we're actually not grading on opposites and balance this time around. If that is probably the best, the most honest way to answer your question. Yes, Truman? What do you mean?
Every time I click enter, it'll just spawn at 9.
Oh, just hit something else and it'll be fine. Yeah. Ah, ha, 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 ha. Yay! Oh, shoot, I knocked it over again. Sorry. Okay. Can I get you guys back up here in 5, 4, 3, 2, 1? No, because it's a warrior time. We got 15 minutes. We got some warrior day. Okay. Okay. Can I get you in 5, 4, 3, 2, 1? Rex, did you know the shortcut coming in? Rex, don't do that thing where you make other people speak with their voice with your mind. It freaks me out. You know that. Rex, did you know the shortcut coming in? Or to this lesson, like yesterday. You did. Okay, then you might have gotten something funny in your calculator, or did you get a nasty decimal? But you also got the funny thing. Who here did not know the shortcut coming in and just got a nasty decimal like the rest of us? Tate, what did you do? What route did you take?
I took y squared
And what number goes in the index? 2. It's the second root. What number, if I multiply 2 of them, gives me 675? And we're going to punch that in, and it's going to be the second root of 675. And hooray, about 25.98. Let's call it about 981, because I realized 25.981. The ACTs rounds to the nearest thousandth, so we should too. Is that going to be a positive and a negative answer there, Tate, or just the positive answer? I'm glad we're talking. So this is squared, meaning it's a number times itself. A positive times a positive would be a positive, so that's good. But if it was negative, would that still work? Is a negative times a negative still a positive 675? It is. So it's plus or minus. Shh. And that's because negative 25.981 times negative 25.981 is about 675. So we're good to go there. That looks great. However, some of you guys knew this trick coming in beforehand. So I'm going to come back to Rex. Rex, you probably used a different button than the rest of us because you probably did not put 2 second root of 675, did you? What button did you use instead? So guys, this thing is called the square root. You'll notice what number is in its index. There is not a number in its index. And you guys, it is the world's only invisible 2. If there is no number in the index, there is an invisible 2. So when you take the square root of 675, that's the same as the second root of 675. And we're like, hooray! Sure, the 2 arrows will still show you the decimal, but hello? 15, what? Now guys, is that the same thing as the 15th root of 3, yes or no? No, it is not in the index. 2 things. Before we move on, there's something I really want to point out. I had a student once say, I hate that that's an invisible 2. Invisible numbers should always be 1. Why would an invisible 1 in the index be stupid? Teach! All right. Can I get you in 5, 4, 3, 2, 1? I know. It's because, guys, if you took the first root of a number, you'd be saying, what number, if I take one of them, is this number? And you're like, is it that number? And they're like, yay. And the thing is that the square really is the most common. The square really is the most common because we're talking about 2-dimensional figures, followed closely by the cube because of 3-dimensional figures, which makes roots over 3 sound kind of weird. Like you're like, why do they exist? But here's the point. What on earth am I looking at? 15 square roots of 3, why is that the exact answer? Which, by the way, that is the exact answer. If you want to know what number multiplied by itself is 675, it really is literally, it is 15 square roots of 3. And here's why. Here's why. It turns out roots can get split up along multiplication, like perfectly. Okay? Watch this. We're going to come back to you in just a minute. Don't even worry about it. Don't worry, 15 root 3. We're going to start talking to you about you in a second. Everyone else, put your pencils down. The square root of 36. What number times itself is 6? Sorry, I just gave you the answer. What number times itself is 36? 6, yeah. The square root of 36 is 6 because 6 times itself is 36. Do you guys agree that I have not changed the square root of 36? Does that still say the square root of 36?
Yes.
Does that still say the square root of 36? Well, I don't know. What's 3 times 3? What's 9 times 2? What's 18 times 2?
36.
Sure, I just changed the order. That's okay. Here's where it gets weird. Does that still say the square root of 36? I don't know. What's 3 times 3? What's 2 times 2? What's the square root of 3? Sorry, what's the square root of 9? What's the square root of 4? What's the square root of 36? Deal with it. Deal with it. Every single one of these expressions is equivalent. Every single one of these expressions is equivalent. I can dice up my little roots, and I can split them however the heck I want to. And here's why that matters. Got a pencil? There are 2 problems on today's self-assessment that I'll have you write down in your planner in a minute that I require 2 answers. Number 1, I want to know what the approximate is. Number 2, I want to know what the exact is. And for the exact, I want it as a reduced root if possible. So the second root of 675, what we're going to do, guys, is we're going to do the same thing that I did to 36 here and break it up into its factors. Who loves factor trees? Yay! They're back, buddy! Huzzah! Okay, what numbers go into 675? Sure, 1 in 675, that doesn't help my tree. 5? And the thing is, I have a calculator, so I can do 675 divided by 5. That's 135. Is there anything I put in here? 5 again. And if I do 135 divided by 5, it's 27. What about 27? 9 and 3, 3 and 3. Now, I have all these prime factors, which is to say, this is the, no thank you, the second root of 3 times 3 times 3 times 5 times 5. Well, that's what I did, right? Do you guys know? That's actually, I forgot to mention. When I was a kid, I loved factor trees because I could factor trees like this all day. And then when they'd say, what do those numbers mean? I'd be like, I don't know. But these are the numbers that if I multiply them all together, I'm going to get 675. 675, another way to write that is 5 times 5 times 3 times 3 times 3. And so that's what I did. I just wrote 3 times 3 times 3 times 5 times 5. Now, guys, if you're wondering where to split this, you can do that. But here's an easier way. What number is secretly in the index here? 2. Do you guys see any pairs of numbers? What do you see? I see a pair of 5s. Does anyone see another pair of numbers?
3.
I see a pair of 3s. I can split this between the stuff that has pairs and the stuff that doesn't. So I'm going to split this like this. The square root of 3 times 3 times 5 times 5 times the square root of 3. Let's punch that into our calculator, shall we? The square root of 3 times 3 times 5 times 5 is, oh, it's 15. Wasn't that nice? That's 15. And then this over here, the square root of 3 is stuck. That's where that came from. That's how you reduce a root. You have to split it up between the stuff that has pairs and doesn't have pairs, or, heaven help us, triplets if it's a cube root. So the exact answer would be y equals plus or minus 15 square roots of 3. Now, lucky us, guys, our calculator will actually reduce square roots for us. Like, if I was like, hey, what's the square root of 999? It would tell me, ooh, is that 3 square roots of 111? It is. Okay? It'll do that for you, but it will not do that for you on the cubes. Okay? So, I've got one more thing for you. Got a pencil? Here we go. Let's see here. Oops. Nope. Okay, got it. Guys, what if I told you that x cubed was equal to 864? Now, guys, well, here's the thing. You can get the approximate for that very easily, right? You could just take the third root of both sides and tell me what it is, but that's not what I want. If I wanted that exactly, I would need to build my factor tree. 864, what do you guys think goes into that? That would be nice. Let's see. Does 864 divided by 4? Oh, hooray. 216 and 4. What else goes into 216? Is that right? 36? 216 divided by 36. Is that true? Oh, look at that. It's 6 and 36. And what's 36? 6 and 6. What's 4? So you can actually keep going, but I'm going to tell you guys right now, what's in the index right here? Do I see a triplet? So let's just leave it at that. I can rewrite that as the third root of 6 times 6 times 6 times 2 times 2. That's the thing. And if you split it up, you'd have a triplet of 3s and a triplet of 2s and a couple of 2s left over. This just makes it a little easier. If I split it up, The third root of 6 times 6 times 6 times the third root of 2 times 2. Well, what's 2 times 2? 4. So that's the third root of 4, and I can't do anything with that. But the third root of 6 times 6 times 6, you're never going to believe what it is. It's 6, of course it is. What number multiplied 3 times is 6 multiplied 3 times? So it's 6 third roots of 4. Whew. If you're having trouble with that, guys, then everything but the last problem on your self-assessment is going to make a lot of sense. Will you guys open up your planners to page 48, please? Page 48. Page 48 under Wednesday, October 22nd. The self-assessment tonight is 7.1. Solving equations with variables. Sorry, solving equations with exponents. Give it a try. That's actually all the time we have for you guys. Those of you on the STAR team can wander around, but everybody else hang out in your assigned seats. That's all I have for you today. Once you get home, work on that guy, and then we'll come back and we'll keep moving on. Trust me, tomorrow's lesson's a lot less intense, so take a deep breath there. Yeah, what's up, Alex? Hey. Oh, in case there was time to work on our self-assessment today, which there wasn't, and it's okay. Hello, Aria.